Alright guys, welcome to Season 2, Episode 6 of our programming course. And this one, the projector doesn't work. There's nothing to project today. Haha, today is a special one. It's going to be more like a TED Talk than anything else. Guys from TED, if you like me, just invite me. You know, I'm happy to receive money for coming up on the stage. So I want to talk about future of programming, and the reason why I want to talk about future of programming is to figure out what's coming in the next 10 years, okay? Because lots of time when I talk to people, especially when we are creating a training plans, what happens is people say, well, should I learn this or should I learn that? You know, what should I learn so in the future that knowledge I can apply, you know, so it's useful, so it's not some technology that stops being useful, and so I can make lots of money, I can easily find a job, etc., etc. Okay, so the whole point of future of programming is to go through everything what is going on these days and give you a little bit of personal, but also kind of what people online think is going to happen. Okay, so that's what we are trying to accomplish today. Give you a little bit of information / overview of everything that is important to think about. What I want to do, how I want to start, is bring you back to 1982. So if we go 40 years ago, and you do this session, Future of Programming, in 1982, you would have a completely different story what you are telling today, okay? Because in 1982 you had PCs, like personal computers. That was a new thing, which had floppy disks and stuff like that, you know. So they had applications like WordPerfect, which was editing text, which looks like pretty much like Nano Editor these days, you know, so it's not a very useful thing. That was state of the art. And then you had these personal computers like Commodore 64 and ZX Spectrum. So if you talked about future of programming, then it will be, as I say, very hard to anticipate everything what would happen, okay? There was no internet, so you couldn't connect things, so there was no PHP, there was no JavaScript, there was no crap like that. Nobody could think of such a thing. There was even very basic networking between the computers, you know, Commodores and these Spectrums, they couldn't network, you know, and PCs typically were standalone machines, you know, you would have it in the office, and if you want to transfer some files, well, save them to the floppy disk and carry it to the other computer. If you drop it, you know, that is typically damaged. So when they would tell you what to do in the next 10 years, they would say, hey, you need to learn this machine code assembly and program processors directly, you know, so that was that, you know, or you can make a spreadsheet, you know, kind of application. You know, they would never tell you to think about the connecting computers together, virtual realities, all these things that we have these days, you know. So when we say future of programming, it's very hard, okay? We know what happened in the 80s and 90s and you know, later. But here's the thing, one guy, some American professor, made an observation, which is kind of almost like a law, that every 2 years the processing power doubles. Okay, so whatever we had 2 years ago, and we can, you know, do this certain amounts of calculations, 2 years later we have doubled that. Okay, so that's a good thing. All right, but it can't double forever. Okay, so we are kind of hitting plateau in that processing power. And the second thing is we don't need it as much. Okay, so do I need my word processing to work faster? No. You know, so most common applications don't need this raw processing power. The second thing what is going on is that it's cheaper and cheaper to build more complex chips. So one chip can do multiple things. So those chips would go in any device. Okay, so that's an interesting thing, you know. Okay, so the devices that don't have chips at the moment will have them in the future, and they will be able to process lots of data. Okay. What else is interesting with these things right now is that people are talking about quantum computers. Okay, so they will be doing million times things faster than what we are doing. So that's kind of things that I'm going to talk about today, okay? So from very small devices to connected devices, we'll talk about blockchain and all the other stuff, you know. So I'll go through this in no specific order. And of course, if you have any questions or comments, if you need, you know, or just tell me what you think on chat or here, we'll cover that, okay? Just for the guys online, I want to show you one little picture, and you know, I'll show you the picture clear like this. Okay. Have you got any idea what this is? Mousetrap. That's a brilliant one. Okay, so this is a mousetrap. All right. I love it. Okay. So actually, this is a picture of the first transistor. Okay, this is the first transistor. So the people who invented transistors, obviously we know transistors are parts of the chips these days. When they invented this, they couldn't even imagine what would happen if you connect billions of these together. Okay, and then put those billions in a little device that you carry in your pocket, okay? So they can't imagine. So even if we understand today's technology, what's invented, we maybe cannot see the whole potential usage of that thing, okay? So I hope that somebody will watch this video 10 years from now and then say, hey, you were wrong, okay? So hopefully that will be fun to do. If YouTube exists in 10 years, you know, that's to be given. So today we have a thing called cloud technology, all right? So we all understand what cloud technology is. So we have these computers in the cloud, we have data in the cloud, we have everything in the cloud, all right? And this is one of the things that will be here in 10 years. So the cloud is not going to disappear as such, okay? So it will keep growing, it will keep bigger, and it will be able to do more things, more and more things, okay? So why is cloud good, all right? We have a thing called centralization, decentralization, you know, and I'll cover this topic a little bit throughout these various areas that we are going to cover today. Because when you go back to 80s, every computer was decentralized. So you have this maximum decentralization. So every computer is doing all the processing. Okay, personal computer, that's why they call it PC, because it does all the processing for you. It holds all the data, and you tell it what you need to do, okay? And it's completely dependent from the computer next to it. It's not connected at all. So if you want to add a new feature, you have to install a new app, which you have to go to the shop and purchase, okay? And if there is a new version, you have to do the upgrade yourself. All right, and that wasn't very easy to do or convenient. Now another problem was that with these computers, you had the data, which if you lose, you lose. All right. So when we talk about web development, and especially cloud development, you have nothing to install as a user. So you go to Google Drive, there's nothing to install, which is great, okay? So there's nothing to upgrade. So new features come automatically. You don't have to upgrade, go to the store, download, buy anything. It's always done. And all the data is in the cloud, so it's safe. You are not going to lose it. It's saved in the cloud, okay? So when you think about this cloud technology, we have various ways of doing this, okay? So we have a backends, of course, and then we have the front ends, which you already know quite a few of these technologies. So it's Angular, React, Vue, etc. There's a thing called Backbone.js, Next.js, Polymer, and so on. What is the cloud? That's a good question. So cloud doesn't exist. That's the funniest part. Because it's just computers in some warehouse which are connected to internet, okay? So, and I go there and they show me the page. So there is no such thing as a cloud. It's just a fancy names for lots of computers where we don't care where they are as long as they do what I want them to do. That's a cloud, okay? So altogether, I go to the website and I run some sort of web application, all right? Now, typically, if you are a designer, you would do Photoshop on your computer. So you would either buy a CD or DVD with Photoshop. These days, you can download it, install Photoshop, and then you would create your pictures, whatever you want. But now, Adobe is working on these solutions to get that as a cloud platform. So you don't have to buy it, run it, update it, and so on. You pay them subscription, and you use Photoshop online, and everything is stored online, so you don't need that. So a very good example would be those Google, what are they called? These web laptops that pretty much don't have anything running on them. You never install anything on them. Chromebooks. You know, we just have a browser and all the apps are in the browser, okay? So basically everything is connected to the various websites, cloud machines, cloud computers, and so on. So, as I said, you know, we will see more and more of that. So all these front-end technologies, especially JavaScript technologies, are the only way that we can create those types of applications. Before we had JavaScript in the browser, we had Flash Player. Okay, so I don't know, does anyone remember what the Flash Player was, but it was some sort of plugin for the browser so you can run little game or little applications in it. So that is dead finally. So we have JavaScript, and it doesn't mean that we will not invent a new plugin for the browser which will do these things better or faster than JavaScript. But JavaScript, pretty safe, as I say, because that is going to do quite a lot. All right, now one thing that we all carry these days, which we couldn't imagine in 1982, was smartphones, okay? So smartphones have a huge computing power, you know, much bigger than computing power of spaceships which landed on the moon and so on, because as I said, every 2 years it doubles, so they can do lots of different things. However, smartphones haven't invented anything new in 10 years. Okay, when you look at the smartphone from 10 years ago and smartphone today, they have exactly the same features. Yeah, they have a better camera, they have a slightly brighter screen, the battery lasts, well, similarly, okay. So maybe there will be invention to have a better battery and the battery will last longer, you know, but that format is really done. Now we can fold it, okay, that's invention, you know, but, you know, at the end of the day, it's a smartphone. It is exactly the same. So when we talk about smartphones,
as one of the things that we are consuming the data on. We already have these laptops and desktops which we are used to. The only other thing what we can see that we are going to have is some sort of wearable device, okay? So wearable device on the wrist, wearable device on your head, like Google Glasses and very many similar products, which already exist to the point, but they are just too expensive to buy if they are any good. And this is the thing, like, imagine I am operating, I'm a doctor doing operation on some patient, okay? And if I have these glasses which assist me with, you know, they can identify things for me. They can give me a checklist what I need to do, you know. They can give me some sort of guide and help. You know, I can pull up x-rays and shit like that while I'm doing this. So for this profession, these glasses are used, okay? And let's say I have a problem in the middle of operation, I can call my colleague and he can see what I'm doing directly there through those cameras and glasses and use that directly. So that would be a very useful thing for glasses for. Okay, but if I'm talking about putting glasses on just to have little navigation, you know, turn left, turn right, well, I already have that on my phone, on the, you know, standalone GPS thing, you know, so who is going to buy glasses just to have it here instead of there? So definitely we will see some new inventions and more usage of these things that we wear on our head as such, or maybe on our wrist and so on. So what are we talking about here? Okay, so we have more computing power, all right, that's number one, okay, because it's accelerating, but it's reaching the plateau. Then we have many more devices, different devices, and we are getting quite a lot of data. Okay, so we have a lot of data that we are collecting through all these things. Not that all of the data makes sense and that it's good, that's a problem, but surely when you imagine what's going to happen next 10 years, we are going to have much more data coming from many more devices, and much more data can be processed on those devices. So, for those devices that are coming and the existing devices that we have, so PCs, laptops, Chromebooks, mobiles, tablets, wearable glasses, VR, crap, okay, we need to write an app. And one of these problems that we have is that we have to write an app for each one of them, same app, okay, and they all in nutshell use different type of operating system and different programming language. But what they all do have is some sort of browser. And this is why these progressive web apps, this is what we typically build, PWA, are interesting because you kind of write code once, most of the code, and then you can compile it for different devices. Right now we are doing Android and iOS typically, but with stuff like Electron and others, we can, you know, generate Mac application, we can generate PC application, and so on. Now, one of the things that what people are trying to do is add more languages, okay? So if you are not very good with JavaScript, but you know Go or you know C#, then you can technically run those inside the browser by certain ways. So you can use different languages to create what we are already creating with JavaScript. I even found that there is a company which will convert PHP into a mobile application, so you can run PHP if you are good at that. So basically for these progressive web applications, these applications which are basically a wrapper, it executes in some sort of browser engine on these devices, and they can be used for anything. We have many, many, many ways to do these things. So another thing what we have as a kind of very famous buzzword now is Web3. And the key of Web3 is decentralization. And it's taking back the control. And it's so funny because Brexit was all about taking back the control, and it didn't work out very well for Britain. So what control are we talking about, and what this Web3 is? Well, I think you ask 3 people and you get 10 opinions, all right? As I stated earlier, the Web3, no, what decentralization is, we had decentralization. So every PC was decentralized. It's its own computer, having its own data, its own programs, okay? So, and it was processing that data on the computer itself. So that's decentralized. As much as you can have it. You can't have more decentralized than that, all right? So if I put everything in a cloud, that's very centralized. So you go to adobe.com/Photoshop and you have a Photoshop. So everybody who uses a Photoshop is using it on their cloud computer. So it's more 10, 50, 100 servers. I don't know how many they have. But everything is centralized. So data is stored centrally, it's processed somewhere and remotely, so that's ultimately central, okay? And then what they are saying, oh, now Adobe and Facebook and all these companies have majority of this market, they run the shit. So we want to give power back to the people. How exactly? How are you going to do that? This is something that is impossible to do, okay? Especially if I said, cloud technology is really useful for us. It has very good benefits. So my data is stored in OneDrive, your data is stored on Dropbox or Google Drive, and it's saved there, Nobody's touching it. Nobody's deleting, messing up. You don't have to worry about viruses and all that crap that we had to worry before. So why should I want to have my data somewhere else? Okay, well, here's the thing, all right? So we can say, well, if you get back your data, then you can sell it. Okay? Yeah, you can sell your own data. Why should Facebook use your data, and Facebook should monetize, because you are the product of Facebook. This is the thing. You are the product. There's nobody else. Okay? They are not selling pancakes or fridges or something like that. They are selling people and the data they collect about the people. So we see various things and various projects about this. Guys, if you don't mind, just over there. So we have various projects that are trying to do this and help people with tokenization, all right? So let's say you have solar panels on your house, and your solar panels are generating electricity, okay? And that electricity goes back to the network, okay? So why don't you tokenize your own solar panels, okay? And then be able to put it on some sort of marketplace where people can bid for it or buy it. Why can't I sell half of my ownership of solar panel to somebody else so they can benefit from it, etc. Okay, so the idea here is that I am my little own, controlling what goes where, who is the highest bidder, etc. Okay, so but that is a lot of work for me. And then if I have to tokenize solar panels, I can tokenize pretty much everything. My water consumption, my CO2 consumptions, everything can be tokenized and sold, and but it looks like too much for a normal user, okay? And then when we talk about decentralization of these blockchain networks, we immediately see creation of very big players. So if they're, I think what they're advertising is, hey, we want to decentralize so the shit doesn't stay with the Facebooks and Apples and so on. Well, they are staying with other dudes, okay? So in that term, you know, I'm just replacing one group of people with another group of people. And I can say Facebook is evil because they are selling my data, all right? But they are providing me the service that I can rely on. I can still talk to my friends and people. If I look at these FTN, whatever, the company we just failed spectacularly, this cryptocurrency bank, you know, they are providing a service which will steal all your money. That's not a very good service, you know, so I kind of don't want to replace one evil with much bigger evil. So what is going to be decentralized? What is the Web3? What is the blockchain, which is obviously powering all this? And I want to explain a few things. So originally the idea, this guy wrote a right paper, this anonymous dude, that there should be a digital currency, okay? And this currency shouldn't be owned by anyone or controlled by anyone, okay? That's the idea. So it's decentralized because everybody is participating in this blockchain cryptocurrency. So we have every country in the world, when they run out of money, they print new money. Okay? So every government does this. Some do a little bit, so we don't feel it. Some do a lot. Every time when they print more money, there is inflation, you know, shit costs. So they print more money, stuff is more expensive for me, okay? Immediately, but my wages don't go up, all right? So when the government controls the money and the banks, if they are mismanaging this money and resources and they run out because they are running their business wrong, they don't get punished, they get to print more. Yeah, and then I get punished for that, okay? Of course, it's not just about printing money, it's printing bonds and all the other, you know, stuff which nobody understands, and I get punished all the time, all right? So if I don't have enough money to pay my rent, you know what happens to me? I get evicted. If the government doesn't have enough money to pay whatever they need to pay, well, they just print more, all right? So there is a reason why governments say, yeah, this is very convenient for us, we'll just keep this. With cryptocurrency, they can't just go and print more cryptocurrencies, okay? They don't control it, okay? And then the bank says, you know what, economy is like this, economy is like that, we'll drop down interest rates or we'll put them up, you know, and we'll lend you the money and you can only get a business loan from us and we are only deciding based on that. You know, so you don't have options. If this is democratized, okay, if this is public, then I would have much more options. I wouldn't be just a Dutch business, Dutch three banks, and Dutch three banks only support that type of business now and not this one. So in theory, this idea about blockchain, originally that was for cryptocurrency, which was this free digital currency, free of control, is a good idea. Now, did this happen?
Not the way it's intended.
Absolutely not the way that it was intended, because, well, there is a huge resistance to use this as a method of payment, so this is not the money. I can't easily borrow money, and there is so much shit going on because people are doing a fast ones over each other. So you have those ICOs, for example, which are to raise capital from backers for your project. So I can create a genuine project and raise the capital. But it's much easier if I just create a fake project and raise the capital, because nobody is going to chase me if I fail. So most of those ICOs were fake, and people lost money. And then there's a speculation about the price, and there's speculation about the cost, and so on. So that failed horribly. So what happened then is then some dudes, I think this guy Vitalik or whatever it's called, is like, hey, let's build a different type of blockchain, okay? And this different type of blockchain wasn't just about one cryptocurrency, it was trying to solve some problems. And one of the ideas is that you can build your own financial institution. So you can have your own cryptocurrency, coins, you can have smart contracts and all that sort of stuff. So you can make your own little bank if you want to, okay? So this is Ethereum, obviously, and that's quite useful. So 8-year-old can make their own bloody financial systems in there, and pretty much they did, okay? So you can build your own financial systems, and one of those will be, you know, successful more or less, they will get lots of money invested, and then boom, they explode somewhere, so they are still here. So this gives power to certain maybe type of people, technical, but also business savvy, and also, let's say, with questionable morals, to jump into this technology and use this technology for whatever the purposes they are. But blockchain, of course, not all of this will fly, but certain cases are very useful. Public record of transactions is useful. So if I have a public record of every house that's purchased and sold, every piece of land that's purchased and sold, that's very useful. You know, who owns this? You know, families are always fighting, oh, it's mine, it's yours. No, there is a record which shows clearly whose it is, okay? So it's not that this is not useful, it has its purposes, but the purposes are not as originally intended, all right? So blockchain definitely, and some of these cryptocurrencies will be with us and they will grow, but as I said with this little transistor idea, we don't know exactly what sort of shape and form will they have at the end of the day. So let me go back to a little bit back first, okay? So you have a technology like .NET, all right? And this .NET was built by Microsoft, all right? And with .NET in version 4.8 or version 4, now there is version 7, you had this new thing called web forms. So you can build a form that you can publish on the web, which people can fill in and send you some data. And we all filled lots of forms online, okay? So this things works. This things just works. And right now there are many, many, many big corporations, companies which still use version 4.8 and the web forms to collect our data, okay? Because they have big Microsoft servers, they invested lots of money, and they work for them, okay? So now there is .NET version, I think 7 or something like that. So there is a huge number of jobs, well-paid jobs, which use this technology, which is not sexy, not advertised. There's nothing, nobody is talking about .NET online. They're all talking about Dogecoin and this coin and that coin, you know. But this is one thing which has a very constant and good usage. All right. There are many older computers, even older than .NET, which are still running COBOL. Yeah, like COBOL was like in 40s or 50s a programming language invented, and these people are now all should go to retire. But the problem is they are still running, and they still need COBOL programmers. Nobody in any school in the world teaches COBOL, okay? So what happened when you were COBOL programmer 30, 40 years ago, and what happens now, because now it's very hard to find a new one, the wages are skyrocketed, okay? So these people want to go to retire, but they can't, and they are making huge amounts of money to stay and maintain and change these little things. Of course, there are not a lot of them compared to JavaScript developers. But what I'm trying to say here is that even if you learn one technology today, and tomorrow they say it's dead, okay? Oh, it will still be very much used for maintenance for this, especially if that technology today was very widespread and adopted, okay? So maybe tomorrow somebody will say PHP is dead. And maybe tomorrow PHP organization will say we are not publishing new versions of PHP ever again. So you have 8, that's the latest one, we go away. That doesn't mean PHP developer doesn't have a job for the next 40 years, because they do. All right? I think most of Facebook is written in PHP, so while they are there, you know, maybe not a good example because they sack lots of people, but you get the point. Yeah, meta. All right. So we have quite a few old technologies that will be used over the next 10 years, and the less people are in that area and the better specialist you are in that area, you will definitely be headhunted for a job and get that job. So it's very good to know one thing very well, all right? Everybody is a little bit scared of things that we see coming up, like solutions no code, low code, okay? So what is that? Well, typically programmers had to write every line of the texts of the program themselves. So that was full code, okay? But we have platforms that require either no code to do certain things or low code a little bit, okay? And you all probably know Microsoft Excel as a very old example of this, because you can do quite a lot of things in Excel with no code, okay, or very low code. So you can select shit and say click sum, and it will sum it for you, average or so on. And then you can write your own functions and so on, and you can write macros, etc. So you have these people who are not really programmers, who end up knowing something that nobody in the office does, and they are some bloody wizards and you want to pay them lots of money and so on. So those type of solutions I'm talking about. But there are lots of products, and I want to cover a few. So they are now called Microsoft Power Platform, okay? So this uses Power BI, Power Apps like Office 365, but also Dynamics 365. Okay, so I'm going to explain this a little bit because they are quite interesting. So Power BI is a business intelligence tool. Okay, you can download it from Microsoft. It's free to use, and it shows you quite a lot of interesting graphs if you connect it to your business accounting and other data, so you can analyze your business and analyze the market and so on, okay? But because it is, every business is slightly different and they want to see a different data, just like in Microsoft Excel, you can write your own little things to understand the data, draw graphs and present it even better, okay? So you don't have to be a programmer, but then you turn out almost to be as a programmer because you're programming this thing to do some things for you. Office 365, you all know that, as I mentioned, Excel would be a great example of that. But they also have a thing called Dynamics 365, and they had Microsoft Dynamics before, and before it was though something else. So that Dynamics is a little bit like AppSource. You can like add applications to do certain things, accounting applications and so on. So you can write those applications relatively easily and connect them and then write macros and stuff to connect and extract information from each other. The only problem with this Dynamics 365 is expensive as hell, and the applications are absolute garbage. Okay, but you know, if you create your own system based on this and create an application for your big corporation, you are going to use this for the next 20 years, and people who can manage this and program this and extract the data and adapt it to the new things which are happening are going to be in high demand. So when I talk about these no-code, low-code solutions, okay, we as developers don't have to be kind of scared of them, all right, because it's not that we are going to lose a job because suddenly everything will be no-code, low-code. These are very specific platforms for specific purposes, okay? Now, another topic that I want to cover is containers. Because before, when we invented servers, we needed servers admin, okay? So you had a server administrator, so that was actually a role in most companies because they would have intranet and stuff like that, and they would hire people to add users, remove users, delete, and all the other stuff that needs to be done. Okay, so you had a physical computer which has like Microsoft Exchange running on it and similar Linux if they are adventurous, and they would serve as a computer that connects everything centralized, okay? Now, virtualization gave us something new, so I can make that computer virtual, okay? So I don't have to have a physical computer, I can make a software computer. So the one big computer, you can run multiple small computers. That's what happens when the power of computers increases twice every 2 years. So before, one computer can only run one standard computer, and now one can run 20. So I can have virtual machines. But what virtualization was and is basically the same as a hardware. It's just software emulated the whole thing. So I don't have a hardware computer, but it's connected. It still runs on a hardware computer. It's just there are 20 of them running in parallel, so they all use a little bit of processor, a little bit of memory, and so on. But in essence, it's like multiple of those operating systems running next to each other. And we all use this. We use every AppSource instance is virtual machine, and you have VMwares and all this stuff, so you can run Windows on Mac, and you can run Ubuntu on PC, etc. Okay, so virtualization, quite fun. But then what the hell is container? Okay, because they keep pushing us these various container solutions. So they say, here's the thing, what if I don't care about operating system? Why the hell do I have to install and configure Apache and MySQL and SSH and so on? And it's different if I do it on Windows, if I do it on this Ubuntu, or that Red Hat Linux, or whatever it is. Why do I care about the operating system? I have to spend so much time setting up the operating system. Why don't I just write one manifest file which will tell what I want, okay? And then what I do is I say run that manifest file. And that manifest file will figure out what I need. So if you need Apache, if you need Node.js, if you need this, it will install the right version for that machine. So I can run the same manifest file on Ubuntu and on PC, and it will create this virtual environment for me just the way that I have it. So then I don't have even a problem of thinking, oh, I'm working on PC, but my end user is going to be Ubuntu, but it's Ubuntu 18, so I have to get this up and running, you know. So this making containers is good, and it's going to be good. It's going to stay because it makes deploying shit easier when it works. When it doesn't work, you have to debug it, and then it's a problem. But the thing is that if you learn about servers, okay, if you are a really back-end developer and you want to create physical servers, or you want to create virtual servers, or you want to create containers, there's lots of jobs and they will be there for you. Now, there are two types of people typically as developers, okay? So one is, I want to learn one thing and I stick with that one thing and always do that thing and be best in that thing. There's always something new to learn in that one thing, okay? And there is another type which every time when a new thing comes out, he throws that old thing that he was working on and jumps on a new platform, okay? Which one is better? Well, the bottom line is both are equally good. Because if you are expert in one platform, as you said what I described before, you will always have a job. That platform is not going to go away easily, okay? So you can, the skills that you use, they will be applied still, and in terms like COBOL and similar, they actually might even be more in demand today than 20 years ago. They pay much more than they were before. The thing with the problems that we have, these are the same problems. We are filling in the forms. We will always have to fill in the forms. So those form filling people who learned and they are really good at filling forms, they'll still be here. And even when we make everything digital, everything blockchain, you will still have a form to fill in terms of like, hey, I need some additional piece of information. I got everything from blockchain, but you know, do you like blue or green shoes to buy? You fill in the form, okay? You can pay by NFC and tick on something, so I don't have to type in my card anymore. Great, but there are still forms as such. So, and if you are jumping every time to something new and exciting, what we have seen in past 10 years and 20, every time when there was something new, it got lots of investment. And people who were first, they got lots of money. They became very influential in that technology, you know. So being there first is also good, okay? So you can get the majority of the coolest contracts, best jobs, etc., okay? So when I talk about programming as such, it's really cool to understand how it works. Really understand how it works and think how the computers work, because that doesn't change. So if you want to try a new technology or be expert in this technology, you still need to understand how the technology works and how to approach the problem solving, how to find a solution. How to find a solution where there's lots of literature, how to find a solution where there are lots of different opinions because everybody is Stack Overflow contradicts each other, and how to fix it when there's nobody on the internet knowing because nobody touch that. You know, so that doesn't matter on the technology that you are using. It's always, always, always going to be the same. Moving on. I can't go talk about this without talking about artificial intelligence. And I like what the guy said in one of these videos that I watched. Artificial intelligence doesn't work. Full stop. You're like, what the hell do you mean it doesn't work? Well, yeah, well, surely it works. Well, he says, the moment it actually starts working, it becomes something else. Okay, it gets a name. And then, so we have a chatbots. Chatbot, yeah. So every time you go on the website, there's a chatbot pops up and say, how can I help you today, and stuff like that. That's not a real person typing those messages. It's AI, but we don't call it AI anymore. Now we call it chatbot. Okay, once we solve the problem, okay, that we intended to do, it has a different name. So I was like, okay, that's cool. I can live with that. So understanding pictures, understanding languages, like natural language and so on, this is solved. Okay, the problems that they have is solved. So when you type a message to the chatbot, if it's a good chatbot, in most cases, it knows what you mean, and it will give you good answer. You know, if I talk to Hey Google or Hey Siri or whatever it is, they can process my voice and understand what I mean. And this is the thing, because in order to get this machine learning to actually recognize every accent, even horrible like mine, and I speak muffled, they train this on a huge number of data sets which now are available for this, okay? So, and then it can recognize all these idiots from Eastern Europe or Scandinavia or something like that. It works, okay? So it's, some of the stuff is solved, and we can just use it, okay? We can find another place where we can plug it in, okay? And, you know, that's great. But as I say, it's typically not called AI, it's called specific thing. But there is a thing called predictive analytics, okay? So the idea is that I analyze some data from the past and I predict what's going to come in the future. And this still doesn't work. After decades, you know, they had this idea, all right? And this is a funny thing, because where would you apply predictive analytics first? Yeah, but in which, where would you apply this solution? Weather. So you would apply it to weather, but I can't make much money out of weather, can I? So even if I tell you very well how the weather is going to happen, I'm going to make ridiculous amounts.
When a comet will hit the Earth.
Hmm?
When a comet will hit the Earth.
Comet will hit the Earth. Well, I'm not going to make money with that either, you know.
Well, you tell them and they'll have to like pay you.
Yeah, but if I tell you which stock is going to go up and down in price,
Yes.
that's what they are trying to do. Okay, but this is a stupid problem, and just think with me a bit. So let's say I build a perfect machine that predicts stock prices. So it knows that this price is $100 today, tomorrow it will be 200. Okay? So what it would advise me to do is to buy it when it's 100, and then tomorrow when it's 200, I can sell it, and I made $100 with one click. Okay? So they predict that. Okay, what happens when everybody wants to buy that?
Goes down.
No,
I mean, it goes up.
it goes up. Okay, so if I'm predicting that it will go from 100 to 200, and I buy it, and there is another guy who also predicts that, and he buys it, and there is another guy who predicts that and buys it, the predictions will be wrong because it will go from 100 to 400, which is good for these guys, you think. Okay, but then another one comes in. So everybody's buying one stock, which goes ridiculously in price, but there's no value in it. There's no value. This company is not making any money, really. It's not suddenly this company acquired 50 new offices and employed 50 more thousand people. It's the same company. It's a fake money. It doesn't exist. That value is just because predictions said it was going to be high, and then somebody else predicted it's going to be high. It's more than they predicted. Boom. Okay, so everybody invests in this company which can't make any money or make some, and nobody is investing in companies which are actually valued something. So your prediction immediately as you predicted it, it's wrong. You understand the problem?
Yeah, I understand. You said that you actually gained.
So you can predict it, you know, if you're first and predict something correct and that it works and then you make money, but so soon as a few others join, then it doesn't work. So the whole stock market idea, where we are trying to predict which company to invest our money in, it's very, very impossible problem to solve easily, okay? And then we have, but people are definitely going to keep trying to solve it, okay? But instead of predictive analytics, we also have, did I type this right? Perspective, I don't know. Analytics which add actions to it, okay? So it's not just prediction, but what is the action, okay? And this is something that is quite cool because if I am doing email advertising, okay, I don't know what message is going to work right now. What email should I send to all the users, all right? I don't know that. What's going to sell my product? So I have to add this analytics which adds actions by shift, okay, for example. Then I can measure which kind of combination of words, messaging, pictures and stuff like that works for my target audience. So I can play with it, do millions of these, and actually predict and create the action to actually buy stuff based on that. So that's a little bit easier to do. Of course, once you get all the bloody emails, buy these shoes, those shoes, those shoes, those shoes, it's again going to stop working by the same comparison, you know, because it kind of beats its own purpose. So that will definitely be a really interesting thing to develop in a data science point of view. But what I'm trying to illustrate here is we have to let data do the thinking. Okay, because I know if I send you an email, say, hey, these shoes were $100, now they are $50, lots of people like discount. Okay, so if I send that email to everybody, it will work for a while, but then people will stop working because they know it was never $100, it's just marketing bullshit, okay? It's always 50, you know. That happens with sofas. You know, every bloody commercial for sofa, when you look at it, it was 6,000, now it's only 1,500. Every single one. But that's how much it costs. So when we are talking about this, we have to let the data do the thinking, because if I do the thinking, I will always come to the same conclusion, do, was, now. But that's not what every day will inspire people to buy my products, you know, so I have to send various versions of emails and see which ones are responding, what's the target audience, and then modify so I get right clickbait or whatever I want. And then, you know, maybe it will work with text messages, maybe it will work work here? I don't know, we will see. Data does the thinking, that Facebook was good at it for a while. You know, their click rates on the advertising was bigger than Google, so data was doing the thinking. This predictive and prospective analysis is interesting as well, and I know that they do quite a lot of this, and actually there are quite a few companies which are doing it in Camelot. Is a hardware maintenance. Okay, so what you want to know is predict when your hardware is going to fail. Okay, because when a hardware fails, then you have to order the part, then you have to send somebody there who is busy, so you are left with 2-3 weeks without the process. But if you predict when it's going to fail, then you can order the right part and prepare somebody to go there when it fails. Or, even better, you can send them before, so they replace the part before it fails. So you minimize this quantity. So when you talk about this kind of stuff, is really useful. And what you said in this thing is, you know, if the comet hits the earth, but then we are screwed. But forest fires, you know, so we can predict, if we can predict when it's going to start and which areas are going to possibly be affected, we can evacuate people safely before it happens, you know, because when the fire is there, you try to evacuate people, then it's a panic, then it's a shit, then it...
They already have something similar with earthquakes.
Well, that's what the people are trying to do, predict the earthquakes, the volcanoes. Yeah, and those are all cool. Those are all very cool, and as such will definitely be history of, not history, in the future of our programming. Investing in those areas will definitely work for you guys. I'm not going to take a break today. I'm just going to do for 10 more minutes, and I'm kind of finished anyway. So bear with me, guys. Few more topics to cover. Open AI, GitHub, Copilot, Power Platform, and other stuff. Okay. So I don't know, have you heard, but I think I mentioned it on one of our staff meetings. There is a thing called Copilot for GitHub. So you can pay $10 a month, and then what they did an AI which analyzed all the code on GitHub, and they can kind of predict what sort of program you are writing, and they can write the code for you. Ooh, sounds good. So what's cool, you can just write a comment. I want to write a thing which will go to the database, fetch me some data, and display me a view. And boop.
That's Blackbox, I think, right?
No, it's called GitHub Copilot.
There's a free plugin called Blackbox.
Could be, yeah.
Same thing.
Yeah, could be. Now, the idea that the new project, what they are doing now is that you say, hey GitHub, write me application which does that. Okay, so just like, hey Siri, you know, bring me some, I don't know, play this music, write me an app. All right, so this is quite cool. And if we play with this, we say, oh my God, in 2 years or 10 years, so any bloody grandpa and grandma will just say, I want an app which does that, and Gitpilot will write it for them. We don't need developers anymore.
Pretty sure it's missing a lot of stuff. When it does.
Yeah, but it's getting better and better.
Yeah.
The thing with all these platforms that you saw, you know, what we talked about earlier, like progressive web apps and so on, they get all these components from everywhere. Okay, and this thing, Copilot, helps us write boring stuff faster, okay? But you still have to connect these components and make them work together. You know, when I talk about these Docker containers and similar, Same thing, when it works it's great, but I have to still connect those things and make them work as one. When I have decentralized services, I still have to connect them, understand them, how they work, and be able to connect them together, you know. So some stuff like boring forms might be very quick to write, using, it's got copilots or CRUD, you know, create, read, update, delete files and the data, but we still have to connect them and make them work as a product. So the objective of a programmer, which was 40 years ago and today, is exactly the same. So what programmer needs to do is get a business problem, okay? You understand a business problem, and then you make a technological solution which solves that problem, okay? So this is always the goal, and this won't go away. So there will always be business problems that we have to sort out with technical solutions, all right? So one thing that is important, or as I mentioned a little bit, there is so many of these little devices which will have integrated IoT stuff. So that is definitely going to become bigger and bigger and bigger, writing the code and connect them. So that's one thing, all these little sensors, but smart fridges, smart tables, smart beds, smart whatever, all right? And one last thing is when we are talking about gaming and especially metaverse, you know, so 3D internets and all that. Well, we have multiple engines and programming tools and development environments, Unity, Unreal, Godot, etc., which again are not going to disappear. They are going to be here in 10 years and they are still going to be huge. They're already huge, but they will be here. Last thing what we are doing and we've seen around is lots of talks about quantum computing, okay? And this is an interesting one because in the 40s, 50s, when they were building first computers, which was size of the room, and each one was custom built by electricians and whoever not, they asked the guy of IBM who was building as the director, well, how many of these computers you think you can sell? And he thought the whole world needs 5 computers. That's the market size for the computer. The whole world needs 5 computers. So as I said, it was hard for him to predict that how these computers will become smaller, affordable, how they will change from the original purpose into something which is much more multi-purpose and powerful. So when we have these current computers and current AI and current stuff what we are doing right now, it's funny when you train AI on pictures like this and then AI thinks that the same dog is doing 3 different things simultaneously, which is impossible because, you know, that's the kind of limitation of where we are at the moment. So if I want to predict the weather really, and if I want to predict fluids, let's say it rains here, where are the fluids going to end up, okay? Which areas are going to be flooded a little bit, a lot, you know, so when I think how fluid distribution works, how space works, etc., those are problems which have require much more data and much more power, and the quantum computing is something that will deliver that power. Right now, it kind of works, but it works with sample problems. So they try to do the sample problem which they know the answer to. So there are a few Americans, few Chinese, and so on. which built this quantum computer, and they gave it a problem they know how to solve, and it solved that problem properly. When I talk about quantum computers in the next 10 years, maybe they will figure out some problems, okay? But once they are solved, they are solved, okay? We are talking about problems in biochemistry and so on, because I don't understand exactly when I drink a pill what happens in my body, how it's released, and all this sort of stuff. It's just too much data, you know. So I need those problems solved for quantum computers. But in the next 10 years, we are not going to have quantum computers in everybody's pocket, you know, running Crush Candy and all the other applications. So that's pretty much it, okay? So I think I covered quite a few things to say that one conclusion, all right? Very hard to predict what's going to happen. So of course the existing technologies are going to continue to be going up and then going down. Some technologies that we are using are going to find its purpose, like blockchain and so on. Some technologies will have very specific purpose, like 3D glasses and all that sort of stuff, quantum computing. They will have a specific purpose. They will not be mass adopted in the next 10 years. Having the approach of what do I want to learn, what do I want to focus on right now, so it serves me for the next 10 years, has to do with the two things, okay? So what kind of developer you are? Do you like to just stick with one thing and learn it really good, because that's fine approach, or are you always going to run and try every new technology as soon as it's released? That's a very good approach. If you try to do both, it doesn't work. Of course, it's just going to confuse you. So that's a good approach. And second thing is object-oriented programming, the way these concepts are working, the ones that I described before, model view, controller kind of things, all this stuff, okay? How the shit works, how it's organized, what are the kind of rules, stupid things that we describe, variable naming and so on. Those are equally important. Doesn't matter if you use COBOL or something completely new thing. So to learning how to think like a programmer and problem solving, that is the key. So every single problem in the next 10 years will be a new problem. You will never solve the old problem. Okay? So every time when you get a new task, it's something that wasn't solved. Okay? So this is that horrible thing that we have to deal with. So when you want to choose, okay, if you choose very new technology, then you will have all these pains with Node.js, things are not compatible, crap doesn't work, there's no documentation. But in theory, it can give you huge advantage because you can write stuff very quickly, okay? And if you choose all technology, then it's very well documented, etc., etc. So both are equally good. And I think that's it for me. That's a short TED Talk for today. See you. You're welcome. There wasn't many questions, so I guess that's fine. Hopefully it was useful. It will either reinforce what you are doing right now or give you little things to think about. So please do write comments, ping me if you need me. But apart from that, thank you very much and have a lovely day. Bye-bye.